In this video, I will show you how to add and subtract complex numbers. Now, a complex number is a number in the form a plus bi, where the a is the real part and the bi is the imaginary part. So if I'm going to add or subtract numbers, I'm going to simply add the real parts with the real parts and the imaginary parts with the imaginary parts. So basically, we're going to treat this I just like we would a variable. Now for problem number 1, we have just an imaginary part plus another imaginary part. So this is just going to be negative 1i, or simply negative I. Okay, looking at number 2, again, this is all pure imaginary, so this is just going to be negative 6i minus 6i is negative 12i. Okay, we're really just combining like terms. Look at number 3. Now we have this negative 7 sitting here. That is a real part. So that's going to, there is no other real part, so I'm just going to have my negative 7 sitting there. But then I have negative 7i is imaginary, and negative I, which is sort of like having negative 1i. So I'm going to combine these imaginary parts to get negative 8i. So this will be the final answer for number 3. Okay, looking at number 4. So again, we have these real parts, 7 and 3, that's 10. Okay, and then we have the imaginary parts, negative 3i and negative 1i. Together that is negative 4i. So that's going to be the answer for number 4. Okay, so when you have subtraction, you really want to distribute this negative sign before you do anything else. Okay, so if I distribute the negative sign, so I'm just going to keep my negative 8 plus 8i. But distributing this negative sign will give me positive 2 minus I. Alright, I just changed the signs. I basically multiplied everything by negative 1. So now I'm going to do just what I was doing before. I've got the real part of negative 8 and positive 2. Together they make negative 6, combining like terms. And then I've got my imaginary parts, positive 8 and negative 1. So that'll make positive 7i. And that will be the answer to number 5. Alright, similarly on number 6, I need to distribute this negative sign here. So just bringing down my negative 4 minus 3i unchanged, but then I will have plus 7 minus 5i. Now I can combine my like terms. So my real parts are negative 4 and 7. Together that makes positive 3. My imaginary parts are negative 3i and negative 5i. Together they make negative 8i. So that will be the answer to number 6. Whoa, okay, we have all these terms here going on. So I just have to be careful because I do have subtraction here. This is going to have to be distributed. Alright, everything else is going to stay the same. So I'm going to have 5 plus 3i plus negative 2, alright, that's not changing, plus 2i. And now I'm distributing, so I'm going to have minus 7 minus 2i. Okay, now I will combine all of these like terms. So first for the real parts, I have 5 and negative 2. So far that's 3. So I have positive 3, and then I have negative 7. So that's negative 4. So that's the real part. Now the imaginary part. I have 3i and 2i. So far that's 5i. And then minus 2i, which takes me back down to 3i again. So plus 3i. So that is going to be the answer to number 7. Okay, number 8. There is no subtraction, so nothing is going to change. So I really can go ahead and just start combining my like terms now. So I've got this 3, and I've got this negative, excuse me, negative 7. Those are the real parts, so that's going to make negative 4 for the real part. And then the imaginary, so I have negative 6i and negative 7i. That's negative 13i so far. And then I have another negative 5i, so that's negative 18i. So I'm just going to have minus 18i. Okay, so that's number 8. Now number 9, I have to be careful because I see this subtraction sign. So that is going to have to be distributed, multiplying everything inside by negative 1. So I will recopy this. So I have negative 7 plus 3i. That didn't change. Here comes the changing. So I will have plus 4, a negative times negative is positive, minus 7i. And then I'm just going to bring down the plus 2 plus 8i. And now I will go back to my combining of like terms. So my real parts are negative 7 and 4. That's negative 3. Negative 3 plus 2 is negative 1. So I have negative 1 now. And now the imaginary parts. So I have 3i minus 7i, that's negative 4i, plus 8i, so that's positive 4i, so plus 4i. So that's the answer to number 9. Okay, how about number 10? Again, I see a subtraction happening, so I will have to distribute, so I will recopy. So I have my negative 2 minus 4i, that's not changing. I have my plus 1 minus 3i, that's not changing. But then I have negative 7 minus 7, where I distributed the negative 1. Now I can combine my like terms. The real parts. Negative 2 and positive 1 make negative 1. Negative 1 and negative 7 make negative 8. So I have negative 8. Now the imaginary parts. I have negative 4i and negative 3i. That's negative 7i. Negative 7i and another negative 7i make minus 14i. So that is the answer to number 10. Okay. Alright, so now we're going to start with multiplication. So that's going to be a little bit different. So watch out for this. I squared is equal to negative 1 by definition. So definitely memorize that. So if I see an I squared turn up, I'm going to write that as a negative 1. Okay, that's really the key. Other than that, I'm going to treat the I like I would a variable. So I'm going to take this negative 3i and I'm going to distribute. So that would give me negative 12i and then positive 15i squared. Now this I squared is negative 1. So it's negative 15, it's 15 times negative 1. So that is going to be negative 15. Okay, so what I have is negative 12i minus 15. Standard form for a complex number, though, is a plus bi. So you really want the imaginary part to be written second. So what I'm going to do is I'm going to take this minus 12i and I'm going to move it over to the other side. So I'm going to wind up rewriting this in the I'm reversing the order. So I'll have negative 15 minus 12i. Okay, so just put the I term second. So that will be the answer to number 11. Similarly, on number 12, little distributive property here, and so I'm going to get negative 32i, and then minus 8i squared. Right, this I squared is really negative 1, so that's going to give me negative 32i plus 8, because it's negative 8 times negative 1 is positive 8. But then I will switch these around, so my final answer will be 8 minus 32i, in that order. Okay, now for number 13. Negative 5 times negative 2 is positive 10. I times I is I squared. Alright, but I squared is negative 1. So this is really going to be 10 times negative 1, which is negative 10. Alright, so that is the final answer for number 13. Alright, for number 14, when you have a binomial times a binomial, you have to do the distributive property twice. So first I multiply the 4 times everything. 4 times 3 is 12, and 4 times 2i is 8i. Okay, and then I distribute the 7i. 7i times 3 is 21i. 7i times 2 is 14i squared. Alright, 7i times 2i, that's I times I, so I get I squared. Remember that I squared is really negative 1, so that means this is really negative 14. Okay, so that's what I really have. Okay, so now just combining my like terms. I've got 12 and I've got minus 14. That's negative 2. And then I've got 8i and I've got 21i. Well, that's 29i. So I have negative 2 plus 29i. So that will be the final answer for number 14. Okay, similarly, again with the double distributive property. So I'm going to have 7 times negative 2, so that's negative 14. And then 7 times I is 7i. And then if I distribute the negative I, that's going to give me positive 2i, and then minus I squared. Okay, so be careful because this I squared is negative 1. So this is minus negative 1, which is really plus 1. Okay, so combining these like terms, I have negative 14 and positive 1, so that is negative 13. And then I have 7i and 2i, so that is 9i. So positive 9i. So that will be the answer to number 15. So for number 16, when you see a binomial squared, don't try to just square these parts individually. Instead, think of this as negative 5 plus 4i times negative 5 plus 4i. Alright? Multiply by itself. So now we're back to our double distributive property again. So if I distribute this negative 5, I'm going to get 25. And then negative 5 times 4 is negative 20i. Okay, and then I will distribute the 4i. So that's going to make minus 20i, and then plus 16i squared. Okay, don't forget that this is really a negative 1. Okay, so that's really going to make this a negative 16. Alright, combining like terms. So I've got 25 and I've got negative 16, so that is going to be 9. And then negative 20i and negative 20i, that's negative 40i. So that is going to be the answer to number 16. Okay, number 17. So doing this in stages. So first of all, we have negative 5i times negative 5i. That is going to be 25i squared times 5 plus 4i. But I squared is negative 1. So negative 1 times 25 is negative 25 times 5 plus 4i. Now I do the distributive property. So negative 25 times 5 is negative 125. And then negative 25 times 4 is negative 100. So I'll have negative 100i. So this will be the final answer for number 17. Okay, now this will be the last one. If I multiply 8 times 7i first, that's going to be 56i. And then I've got times negative 4 plus 8i. Distributive property. Let's see, 56 times 4 is 224. So that's going to be negative 224i. And then 56 times 8 is 448. So this will be plus 448i squared. Watch out, because I have I times I, so that's I squared. Remembering that I squared is negative 1, that really is going to make this negative 448, okay, with no I. And remembering that the imaginary part goes last, I'm going to go ahead and say minus 224i and write my final answer in that order. So now I will show you how to calculate the absolute value of a complex number. The bottom line is, if you have the square root, the absolute value of a complex number a plus bi, that is going to equal the square root of a squared plus b squared. It's as simple as that. So looking at these complex numbers, you can see what your a and your b is. So, for example, this one is going to be the square root of negative 6 squared plus negative 3 squared. So that's going to be the square root of 36 plus 9, which is the square root of 45. And then simplifying further, square root of 45 is the square root of 9 times the square root of 5. So that is going to be 3 radical 5. So that's the answer to number 19, will be 3 radical 5. Number 20, we're going to have the square root of negative 2 squared plus negative 1 squared. Alright, that's my a and my b. So this is going to be the square root of 4 plus 1. So that is going to be the square root of 5. And that cannot be simplified any further. Alright, so for this one, number 21, it's going to be the square root of 6 squared plus negative 9 squared. So that'll be the square root of 36 plus 81. So that's going to be the square root of 117. Now at a glance, I know that this is divisible by 9 because add up the digits. 7 plus 1 is 9. So I know this is divisible by 9. So let's see, 117 divided by 9, that's 13. So this is 9 times 13. So this will be 3 radical 13. So that's the answer to number 21. For number 22, we have the square root of 3 squared plus negative 9 squared. So that'll be the square root of 9 plus 81. So that'll be the square root of 90, which clearly is 9 times 10. Square root of 9 times square root of 10. Square root of 9 is 3, so we have 3 radical 10 for the final answer. For number 23, we have the square root of 10 squared plus negative 5 squared. So that's going to be the square root of 100 plus 25. So that's the square root of 125. Well, 125 is 25 times 5. So the square root of 25 is 5, so this will be 5 radical 5. So that'll be the final answer for number 23. And then number 24, we have the square root of 8 squared plus negative 10 squared. So that'll be the square root of 64 plus 100. So that's the square root of 164. Because this ends in 4, I know that this is divisible by 4. So it turns out that 164 divided by 4 is 41. So this is the same thing as 4 times 41. So this is going to be 2 radical 41. So that'll be the final answer for number 24. Alright, that's going to do it for this video. I hope it was helpful, and I will see you on the next video.